So it's pretty hard to follow Laura's talk being all about how do you actually communicate something highly technical in a way that's understandable to users. And this is a highly technical talk filled with jargon, which, oh well, we'll see how we go. For those that are used to my talks, they're typically a lot rambling, but we'll get somewhere in the end. Talking today about Swift data and particularly history tracking, which is a new feature released in this year's releases, so iOS 18, macOS 15, Vision OS 2, watchOS 11 if you're crazy enough. Actually not even sure if it's supported on watchOS, but if you're running a database on watchOS, you're probably doing something wrong. Okay, the why of history tracking. With apps these days, you tend to fetch data from a database at a particular point in time. So say you've loaded a screen, everything is fetched at that point. You want to show it, you show 5, 10, 100 items on the screen, and that's all good for that point in time. What then happens, sorry, hay fever is an absolute bitch at the moment, so my voice is just bad, but we'll get through. So, okay, the why of history tracking. Got data on a screen, that data is for a point in time. Something happens and your data gets updated. You then are faced with an issue of, well, how do you go from point A to your new point B? That's the why of history tracking, to be able to go through that. The where is a bit more about, okay, so you've got device A is your iPhone. Your iPhone goes into your pocket, you load up an app on your Mac, you do a few things. Those two devices need to sync. Chatting with Fletch just before, he mentioned about how do you then resolve conflicts, and I said, that's a good point, I don't know the answer. For a lot of Swift data stuff, you've got a fair bit of Apple magic happening, which is around the, there's a particular core data term I'm trying to remember, which is, yep, okay, that term's gone, but it is to do with syncing your core data store up to your iCloud, so CloudKit, and just doing all of that and organizing the changes and the syncs and everything, which for a large part is Apple magic, mainly because we don't have any actual visibility into what happens there. Okay, that's a bit of a ramble on the where. Now we look at the how. So the how is, what does this actually look like in code? For those that have been around for a bit, there is a land before time, and by that, as well as a really cool movie, is NS Fetched Results Controller, which is how you would get an idea of any changes to a core data store back in a world of UIKit. So let's have a look at how you would create one of those. The Fetched Results Controller, you provided a request. All of my code examples today are going to be very high level, mainly because I'm wanting to give a good idea and understanding of the overall context rather than the specific, here is how you want to solve it in code. So put in a request, your managed object context is your interface between your stuff and the actual store. If you want to section it, You can do that in the fetch results controller, and you can also cache it. But the magic really happens in the delegate, where when you set up a controller, you say, here is your delegate. Typically that's just the view model, or if you're really after a world of pain, the view controller as the delegate. And that way, when a change happens in your fetch results controller, it will say, okay, delegate, here are all of the changes. So go run your code. This code is taken from Apple's documentation. As you can see there, it's dealing with the table view, so good old UI kit. Couldn't find an Objective-C version of this. That would have been troll, but I've got it here in Swift. So when you get the changes, it'll look for things like, it will give you details around your inserts, your updates, your deletes, and stuff like that. The fetch results controller is designed around having your data returned and stored in an sort of a sectioned array, really, because you've got a lot of these calls, words are failing. A lot of these calls use index path, which has like your section and your row. And that maps well to table views and collection views and all the stuff from over 5 years ago that most of you either don't know about or have completely forgotten about. Anyway, so what happens here is you just go through all of your changes, and the controller will say to the delegate each time there's a change, here's a change, here's a change, here's a change. So if you're doing like 1,000 changes, you'll get this 1,000 times. Becomes messy and slow and all of that. Now we're on to the fun stuff. So we've seen what it used to be like with fetched results controller. Now we've got it with the history tracking. With history tracking, you are dealing with points in time. So when you ask your context for everything from a point up to a point in time, you get a token, and you just store that token so that the next time you go, okay, give me everything from token to new latest point in time, and so on for each change. In order to create these history transactions, you need to create a descriptor. You then assign a predicate to the descriptor. This code example is using the predicate macro to define it, which is nice, very Swift-like syntax. And here all we're wanting to check is that the token is newer, which is pretty cool. Once we get all of those transactions back, we then need to do our iteration over them and go, okay, is this a change we're after? So we look at the transactions. A transaction is a collection of changes. Those changes can be everything that a context has done up to a save. Even with your context, you can do transaction blocks in it, which is good if you want to do unrolls and stuff. There are a few different ways of handling it, but this is what it is. Each transaction has a change, and those changes are your inserts, your updates, and your deletes. Or an unknown fourth thing that may or may not come about in the future, which we're just handling there. So for inserts, you would want to do stuff like, okay, make sure that any associated data is updated and stuff like that. For your updates, this is are we displaying our particular our particular object on screen? If we are, we want to then go ahead and update it on the screen. Deletes, again, are more for the particular removals. This code example is around a single database object being shown on screen. So the only changes we're interested in are the updates to that value. We could be interested in deletes as well, because if there is a delete of this particular object, we would want to visually pop back our navigation stack, dismiss our modal, something like that, in order to display to the user that this particular value isn't there anymore. Now, all of this is good in a very linear fashion, because with, say, your fetch results controller, Apple's underlying systems are telling your stuff, here's a bunch of updates. With this history tracking style, you are going, okay, please give me every update from a point in time. Now, you could do that on stuff like on a peer callback in SwiftUI and stuff like that, which is pretty much this thing has come on screen. Is it out of date or something like that? There is another option, and that is tying it back into NS notifications or notifications. NS, not many people not many people know about the old NS prefix, so it's just a notification in Swift. What we want to do is listen to this and then go, okay, put it onto a async stream or something like that, and then your code will observe changes on that stream and go, okay, we have a database save, please give us every new transaction, and then do your iterations through that. Model context.didSave is there for the notification name, so it's a very swift way of handling it. And that's pretty much it for the talk. Did anyone have any questions? Have I completely bamboozled everyone?
Did you like using it?
Yeah, it makes a lot of sense.
Okay.
It really fits in with a very swift way of writing everything. You're not having to sort of deal with publisher streams or anything like that. Fetch results controller itself, you would need to do magic to get the results into a publisher stream or something and combine. Doing it in an async concurrency way is a bit nicer. You can see the linear flow of the actual code a lot there, so you've got less cognitive load when actually trying to understand what's going on.
Any more questions? No? Well, thank you, Amy.